Hello dear aspirants, this is Dr. Sourav sir's classes. Our contact number is 9836793076. Again I am repeating our contact number which is 9836793076 and our email ID is souravsirclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID, then our team can arrange it out clearing session for you. After that, you can join our regular batches, our one-on-one sessions and our online classes. So that will be beneficial for your preparation of upcoming examinations like ISI, CMI entrance tests or like your semester exams and CSI and NET, GATE, NBHM, TIFR, etc. So please feel free to contact if you need any help from us. Okay. So now we are going to solve a problem which is appeared in the ISI JRF question paper, and the question is telling us that consider the differential equation y double dash plus py dash plus qy equals to 0, where p and q are continuous functions on closed interval 0 1. For a non-zero solution y of the above differential equation, define z of y is equals to x belongs to closed interval 0 1, yx equals to 0. Prove that for any two non-zero solutions y1 and y1 and y2, either z of y1 is equals to z of y2 or z of y1 intersection z of y2 is equals to 5. Okay, so let's see what can we do. Okay, so now my screen's ready. Okay, so to prove that for any two non-zero solutions y1 and y2 of the differential equation which is given as y double dash plus py dash plus qy equals to 0, where our p and q are continuous functions on a closed interval 0 1, either z of y1 is equals to z of y2 or z of y1 intersection z of y2 equals to 5. So okay, so now the key observations of this question will be what? So the linear independence and Wronskian will be the first. So the solutions y1 and y2 are linearly independent if they are Wronskian. That means w of y1 y2 of x, that is equals to what? The determinant of this thing y1x y2x this, and that is equals to what? That will be y1x into y2 dash x minus y1 dash x into y2 x. If this is non-zero for some x belongs to closed interval 0 1. So if y1 and y2 are linearly dependent, then our y2 is equals to some c1 for some constant c not equals to 0, which implies our z of y1 is equals to z of y. So now we are going to understand the Strum separation theorem. So let me write it in the screen. So for two linearly independent solutions of the differential equation, the zeros of y1 and y2 interlace. That is, between any two consecutive zeros, y1, that is between any two consecutive zeros of y1, there is exactly one zero in exactly one zero of y2 in between it and vice versa. So this implies our z of this thing intersection z of y2 is equals to 5 unless our y1 and y2 share all their zeros, in which case we will get z of y1 is equals to z of y2. Okay. So now we are going to prove the statement. So case 1. So our case 1 will be what? Then we will get our y1 and y2, they are linearly dependent. So then we will get our y, or we would write y2 is equals to cy1 for some c not equals to 0. Now for our y2x is equals to 0 if and only if our y1x equals to 0. So thus from this we can write our z of y1 is equals to z of y2 by the definition of z. Okay. So now the case 2 will be if our y1 and y2 are linearly independent, then by the Strom separation theorem their zeros interlace and hence they cannot share any common zeros unless they are identical, which would make them linearly dependent. So from this we can write this thing easily. So the conclusion will be what? So for any two non-zero solutions y1 and y2, either our z of y1 is equals to z of y2 if they are linearly dependent, or z of y1 less z of y1 intersection z of y2 is equals to pi if they are linearly independent. Thus the statement is proven for any two non-zero solutions y1 and y2, either z of y1 is equals to z of y2 or z of y1 intersection z of y2 is equals to 5. Okay. So we are done here. So so we can tell that. So we proved the statement which is given in the question. Okay. So again, I am telling that if you have any other mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay. Hope you understood, guys. Thank you.